Hello everyone. I am Siv Prakash, Research Scholar, Department of Electrical Engineering, ITBHU. Let's start the session. Question number first is given. Consider the hybrid switch capacitor converters shown below. Input voltage and output voltage also given 10 volt and 15 volt. Let's ask about the duty ratio. In this circuit, you use the charge balance equation. We have the capacitor given, two capacitor is given, C1 and C2. Find the charge balance equation. You know about the charge. Q is equal to CV. First of all is Q is 1. Sorry, this Q is a charge, not switch. Q is 1 means this switch and S is closed, S bar is open, and this switch is closed, will close, and this one is open. And this is switch is closed, and circuit form like that, and this one also open, and C2 current flow like that. If you want charge for Q1, C1, then you can find C1 with capacitor and voltage across this one V in, and from Q2 voltage is C2 into V naught. This one for Q is equal to 1, and when Q is equal to 0, this one switch, this switch is closed, circuit form like that. Then charge Q1, some voltage applied here, V in minus V naught, C1 V in minus V naught, and Q2 is same for V naught. Charge balance means average charge of the capacitor is 0. One time period is charge and second other time period is discharge. When Q is on, so Q is 1, the capacitor will charge, and when Q will 0, then capacitor will discharge. I think Q1 into dt plus Q1 into 1 minus dt. The switch is on and switch is off. Is 1 d C1 into V in plus 1 minus d, sorry, dt, and C1 V in minus V naught. For average, take a total time period, tt cancel out, this one is 0 for average capacitor charge, and t here cancel out, then finds C1 dV in plus 1 minus d C1 V in minus V naught. C1 take common, then find final equation is dV in plus 1 minus d V in minus V naught equal to 0. Solve it. Minus dV in plus dV naught equal to 0. dV in cancel out, and find d is equal to V in minus V naught divided by V naught. V in is given in 10 volt, sorry, V in 10, V out 15 divided by 15. this is minus, this one plus, this one minus, sorry, so 15 minus 10, it is equal to 5 by 15, 1 by 3, 0.33 duty ratio. Okay. Question number 2 is given, consider a Plonk transfer function given 4 divided by s plus 2, s plus 3, and controller scheme also given. GC is the controller and GP is the Plonk transfer function. GC is given like a PID controller, KP plus KI by S plus KTs, and given here the maximum overshoot MP 10%, and settling time is given 5 seconds. One pole also given, I think minus 10 into zeta omega n. Then find Kp, Ki and Kt respectively. This one question number first. Take a charge balance equation. Like a Q1 is the charge of capacitor C1 and Q2 for the charge of capacitor C2. After that, charge balance equation is the average charge of a capacitor is equal to 0, and same as in inductor is the average flux of the inductor is 0, will 0. Same thing apply here and find D. Okay. Here is given a Plonk transfer function and PID controller. Both are combined here to find final GS transfer function, open loop transfer function. I written like that. GP Plonk transfer function and GC is controller. Here you can also solve this GC. If you take IS as a LCM, then you find KD into S square plus KP into S plus KI. GP is equal to 4 divided by S plus 2, S plus 3. And this one KD into S square plus KP into S plus KI divided by S. Okay. Now find characteristic equation. You know about the 1 plus GSHS. HS is given here is 1. The unit feedback control system. 1 plus 4 KD into S square KP into S plus KI to solve this. Find S cube plus 5 S square plus 6S. So 2 plus 3 here, not 2 plus 2. 3 and 2 is 5, 3 times 6S is equal to 0. And solve it to find x cube plus 5 plus 4 KD into S square plus 6 plus 4 KP into S plus 4 Ki. Given equation number first. This is the characteristic equation of the plant and control system both. They are given a maximum overshoot MP is equal to 10%. We know about MP, maximum overshoot equal to minus by zeta under root 1 minus zeta square. If you solve like 10% is 0.1, solve for the zeta here, then we find zeta that is 0.591. And settling time also given, five seconds. Settling time is 4 divided by zeta omega n is equal to 5. Find zeta omega here 0.8. If you divide by zeta in the zeta omega n, we find omega n. Omega n like 0.8 divided by 0.591, 1.35. You find zeta and omega n on this question, and you know about the standard equation, third order equation. Some pole like that, s plus a I have taken, and the second order is s square plus 2 zeta omega n, sorry, s omega n square is equal to 0. Sorry. Here is given s, one pole is also given here 10 zeta omega n. If you taken like s is equal to minus 10 and zeta omega n is 0.8, then you find s is equal to minus 8, s plus 8 is equal to 0 is the coefficient. It means a is equal to s plus 8. S plus 8 here, and s square plus 2 zeta omega n, zeta omega n is 0.8, 1.6 s plus omega n square 1.3 whole square omega n, and find 1.83. Solve s cube plus 9.6 s square plus 14.63 s 14.64 like that. Question number second, and here is question number first. Compare the both equation. Compare here, we will get 5 plus 4 kT is equal to 9.6. Find kT value here, I think 1.15. Second one, 6 plus 4 kP is equal to 14.63. Find value of kP 2.15, and third one 4 ki is equal to 14.64. Find ki 3.66. kp, ki and kd 2.5, 3.66, 1.415. 2.15. I think this one kp, kd, kp, ki, and this one kd. Dios 2.145 also like. Question number third. An ideal boost converter And this conventional boost converter has the following parameter: V in, V out, resistance and switching frequency. Inductance also given. On time 4 microsecond. T on is given 4 microsecond, and FSW is given like 100 kilohertz. Find total time period from this. Ts 1 divided by 100 into 10 to the power 3. And find like 10 microsecond. Then find duty cycle D. D is equal to T on divided by T, total time period is 0.4. We have duty cycle. Happen continuous or boundary condition or discontinuous condition. What happened? See here, like a boost converter, ideal boost converter is V in, V naught is on R, C, L, Q. We know here for the boundary condition, IL inductor current with respect to T is on time period dt, 1 minus dt, total time period this one is T. And this one is charging curve, and this one discharge. For the boundary condition, del, if you know, see here for the average inductor current, this one IL. You say there here for the IL is equal to delta IL by 2. If delta IL by 2 is greater than the IL, if you say like that, if IL is greater than delta IL by 2, this one continuous conduction mode, and this if IL is equal to delta IL by 2, this one boundary condition, and if IL less than delta IL by 2, that means this one is the discontinuous conduction of the controller. Then find IL and delta IL. You see here, for IL, when switch is on, then this current is flow like that, and this one I naught, IC, and when switch is off, then this IL flow like that. If you take a average IL, 1 minus D is equal to I naught. It means when the switch is off, that time whole inductor average current is given to the output, because of average capacitor current is 0. This one average value, not instantaneous value. Then find I naught. I naught is given 12 ohm and 12 volt. Then we find I naught. Average I naught is equal to V naught by R. V naught is given 12 volt and 12 ohm resistance, 1 ampere. I naught. IL is equal to 1 divided by 1 minus D. D is equal to 1, 0.4, 0.6. IL is equal to 1.67 here. find delta IL. Ripple inductor current, ripple current boost converter. Ripple inductor current means this one current. When switch is on this time, then voltage is across the inductor is V in. Then we say that V in into dt by L. You can also say like the dV dy by FL. Find delta IL. V in given 10 volt, D is 0.4, and switching frequency 100 kilohertz. To inductor is given like 10 microhenry minus 6. This one is 4 ampere, and delta IL divided by 2 is 2 ampere. Then see here, IL is less than of delta IL by 2. IL is given like 1.67, less than of 2 ampere. It means this one is the discontinuous conduction. Okay. Question number 4. And a conventional boost converter that is switching at 100 kilohertz is supplied with an input voltage that varies from 6 volt to 10 volt. V in given 6 to 10 volt. This one is minimum value, this one is maximum. The output is regulated by PWM technique. It means the output voltage is constant. Load resistor is also given. 5 ohm is connected across the output. The value of inductor is 30 microhenry. The maximum ripple in inductor current is given, delta L max 1.25 ampere, and it says that the minimum value of output capacitor to keep the maximum output voltage ripple is 0.1 volt. Delta Vc maximum 0.1 volt only. Neglect of losses because it continuous conduction of resistor. First of all, this information is given like delta IL is equal to maximum delta IL 1.25 ampere. Then same boost converter, you find delta IL dV in divided by FL. V in boost converter, V naught is equal to V in divided by 1 minus D. Then you replace by V in, because of V in by D and V naught is constant, I will take a V naught like that, D into 1 minus D V naught divided by FL. Take as a function like I take like y. Find the maximum, then differentiate with respect to duty cycle, and find 1 minus 2d V naught divided by FL. For y maximum, take dy by dd is equal to 0. Then find 1 minus 2d V naught by FL is equal to 0. It means D is equal to 0.5. When D is equal to 0.5, the delta IL is maximum. and delta IL will max d 1 minus d V naught divided by Fl. We know this one is given 1.25, I think 1.25. D is also known 0.5. 1 minus D also 0.5. V naught is not given. F into L frequency is given 100 kilohertz and 30 microhenry. One, two, three, five, six. All of zeros cancel out. In this we find V naught. V naught is we'll solve this and find V naught like 15 volt. If V naught is 15 volt, then also you know I naught is equal to V naught by R. 15 by 5 is equal to 3 ampere. Second condition is given maximum ripple voltage. It means delta Vc is max. When this one I into D divided by Fc, when D max, it means a maximum delta Vc. T max it means V naught by Fc. You know D max duty cycle is V naught minus V in divided by V naught, and due to cycle maximum when D V in is minimum. And is given like a 0.1 volt, 0.1 volt. I naught is given 3 ampere. Fc V naught is 15. V in minimum 6 divided by V naught 15. Find here C value 0.1 into 15. So 3 into 9 divided by frequency 100 kilohertz. Into this one 15 plus 180 microfarad. Okay. Question number 5 to 8 is given. Consider the following ideal boost converter circuit shown below to answer the following questions. Here also the boost converter and the PID controller is used. Here reference of 5 volt, it means output reference 5 volt but multiply by 21 by 24 in output. That means if you find output voltage like 5 into 24, this one is the output voltage 120 volt. Actually V naught voltage here taken V naught voltage is divided by 21 by 24 and reference voltage set by 5 volt. That means that's why V naught is equal to 5 into 24. The overall transfer function is given. Output, it means V output divided by D cap is given this one. and controller transfer function is given. And the required phase margin 45 degree. Ask about the gain crossover frequency and Ki, Kd and Kp. First of all, find V0 by d cap. I think this one I solved many times. I am writing here directly. V output divided by V in. Find the average inductor voltage and the average capacitor current. After that, taking a perturbation, and then after that find V0 by d cap. To solve this, you find 1 minus d r1 minus d square minus s into L divided by r 1 minus d square plus SL s square L CR. The transfer function. Boost converter. The different for the buck converter and buck boost converter. If you R1 minus D common here, then you find V0 by D cap D. You take R1 minus D common, then find S L divided by R 1 minus D square. I take L like downside here. Here 1 plus S R 1 minus D square divided by L plus S square divided by R cancel out. 1 minus D square divided by LC. It is written like that. You see this 1 by W RHP and Q omega naught divided by omega naught square. Same thing I am writing this one. Then we find omega RHP is equal to R 1 minus D square divided by L and Q omega naught R 1 minus D square divided by L, same, and omega naught. Actually omega naught square, that square divided by LC, that's why omega naught is equal to 1 minus D divided by under root LC. This one is given dV no GDO. GDO is given V naught divided by 1 minus D. All of it is given here. All the value given like R, T, L. You calculate all of thing. And taking PID controller. PID controller is given Ki1 plus K1S plus K2S square by S TDS plus 1. I am taking this one. Ki 1 plus K1S plus K2S square divided by S tau S plus 1. Here k1 value also given, like 1 by q omega naught, this one. K2 is given 1 by omega naught square. And tau d is given 1 by omega RSP. Same thing, we find omega RSP here. An overall transfer function is given like that. All of the controller and this gain also consider, and this one also consider. All of things we will consider, then find plant transfer function. So it is also controller and plant transfer function like that. And this one for modulation index and H are 1 by 24. So we find like Ki to GTU first writing a controller 1 plus K1 S plus K2 S square divided by S tau d plus 1 into plant transfer function. GTU multiply by here, then we take this one. This one omega RHP, 1 by omega RHP is also really, you can written like this one is tau d, 1 by RHP is this one, then 1 by you written 1 minus tau d into S and divided by 1 plus K1 is 1 by q omega naught, and q omega naught is equal to r 1 minus d square by L. This one is given K1 here, S, K1 into S plus this one is K2. This one value of K2. K2 is omega naught square. K2 into S square. So see this one denominator cancel out from this. We find overall transfer function Ki into GTU 1 minus tau d into S divided by S 1 plus tau d into S into FM into H also. Is given a phase margin in the question is 45 degree. Phase margin is 180 plus 5 in GS of GS. Then find angle of GS. GS is here in the denominator only, then it is given 90 degree. This one is given minus tan inverse tau d into omega minus this one tan inverse tau d into omega this one is phi. Put the value here. Pm 45 degree 180 minus 90 degree minus this one is 2 tan inverse tau d into omega this one minus 45 degree equal to 2 tan inverse tau d into omega you can find tau d into omega here tan 22.5 degree tan 22.5 degree is 414 omega is equal to omega gc at omega gc is a find out phase margin tau d into omega gc is equal to 0.414 that means omega gc is equal to 0.414 divided by tau d 1 by tau d is equal to omega r hp 414 into omega r hp omega r hp is given r1 minus dl d whole square divided by l to solve this then find like 90.2 into 10 to the power 3 and q omega naught if you solve this one is same 90.2 into 10 to the power 3 and you find omega naught like a 6.96 into 10 to the power 3 put the value here 0.414 into 19.2 10 to the power 3 find omega gc is 7.95 into 10 to the power 3 radian per second. If you convert into frequency divide by 2 pi and find 1.26 kilohertz. Next question is given 1.26 ki value, kp and kd. And first one find ki. We find gain of this system at omega is equal to omega gc. Omega gc I find and I also I find omega gc like 7.95 into 10 to the power 3 radian per second, and this one is at omega gc is equal gain is equal to 1 and gain is given fm into h into gdu so 1 minus this one 1 minus under root 1 minus tds and 1 plus tds is magnitude of the both same of the system is same. 1 minus tds and 1 plus tds magnitude is same, that's why this one cancel out, only s is remaining here. S is given like omega gc magnitude of this. Ki is missing here, ki also here, so ki gds into f into m and 2h. find the value ki. Ki is equal to omega gc divided by fm into h, which is gdu. gdu is given v naught by d, v naught divided by 1 minus d. And put fm is given like 0.25, this one given 105.24. gdu is given v naught divided by 1 minus d. v naught find 120 volt. Then find ki 2.54 into 10 to the power 3. All the value is known here, so 0.95 into 10 to the power 3. Ki is fine. Kp and Kd value fine. Okay. For Kp and Ki, for Kp and Kd, take a GT. I will explain controller. GS is given Kp plus Ki divided by S plus Kd into S divided by Td tau d S plus 1. Let us find the value of K1 and K2 from the transfer function PIT. Find K1 and K2 and compare to this one K1 K2 and here, and this one is K in term of Kp Ki Kd, K1 K2. Compare this and find the value of Kp Ki and Kd. You can find all of them. Take LCM and find S 1 plus tau d into S. This one is Kp and to 1 S plus S tau d plus Ki 1 plus tau d into S plus Kt into S square. This one S square, take amount, take together S square, then we find Kd here plus Kp into tau d S square, and take together S. If you take S together, then find Kp plus tau d into Ki S plus remaining thing S plus Ki is the remaining only. S 1 plus tau d into S. Take Ki common. To take Ki common from this, we find 1 plus this one divided by Ki, it means Kp divided by Ki plus tau d into S, and divided by Ki here plus Kd Kp into tau d to S square divided by S 1 plus tau d into S. This one is fine. Denominator and numerator is K1 and K2. From this you see about the K1, this one is K1 and this one is K2. we can written k1 is equal to kp divided by ki plus tau d, and k2 is given kd plus kp into tau d divided by ki. And we can also find k1 is equal to 1 upon q omega naught, and this one like q omega naught is 19.2 into 10 to the power 3. Then we find 20.83 microsecond. So k1 is not in second, and I will say like second. And value of k2 is 1 upon omega naught square, 1 divided by omega naught. Omega naught is equal to 6.96 into 10 to the power 3. .020 into 10 to the power minus 6. K2. Take here k1 is equal to 20.83 kp. I do not know ki value I find 2.54 into 10 to the power 3. Microsecond, I think 10 to the power minus 6. Plus tau d. Tau d value know here. One upon omega RHP. This one 1 by so this tau. We find tau is I think 2.08 micros. This one 20 into 10 to the power minus 6 minus 52.08 into 10 to the power minus 6 into ki 2.54 into 10 to the power 3. Then this value if you see there, this one is a negative value and gain cannot be negative. That means you can say kp is equal to 0 is a minimum value of gain. So kp is equal to 0 only, not a negative value. And next find from the k2 is kt plus kp into tau d divided by ki. If you take a kp is equal to 0, then find kd divided by ki is equal to k2 is equal to 1 upon omega naught square 0.020 into 10 to the power minus 6. Find value of kd here 0.020 into 10 to the power minus 6 into ki Ki is given 2.54 into 10 to the power 3. So Kd value is 5.2 into 10 to the power minus 5. Kd's value is 5.2 into 10 to the power minus 5. Kp 0. Ki is 2.54 into 10 to the power minus 3. This one is 0, and Ki I find here 2.54, 2.5, and next one is 5.2 into 10 power minus 5. Also 5. Okay. Next question is given. Consider the buck converter circuit. When the figure is to answer the following question. This one the practical buck converter. Is given a state IL VC. Duty ratio is also given. The equivalent steady state value. You know about the X dot is equal to A X plus B U. In a steady state, you know X dot is equal to 0 in a steady state. Then you find 0 AX plus BU, and find AX. Find X is equal to, and find minus A inverse B into U, where U is equal to Vs input voltage. You find matrix A matrix and inverse of this, and find B matrix. I have written here. If switch is on, this one is closed, this one is off, and circuit flow like that. Current. Here find Vc value and V naught value. Not given directly. I will written where Q is equal to 1. R1, this one also given in the question same. This one L, RL, RC, R, and this one is a V naught value. This one IL, IC, and I naught. See here, you can see here only this portion. I have written like that. IL current flow here. This one R, total voltage V naught, RC, one VC, IC, and this one I naught. I have written like IL is equal to IC minus IC plus I naught. IC is written like that V naught minus VC divided by RC plus I naught written like that V naught divided by R IL. You take LCM, then find R into RC into IL is equal to V naught plus VC into R plus V naught into RC, and find the value of V naught here. You find value of V naught, right? R into RC divided by R plus RC, take LCM, take a common R V naught, then find R plus RC into IL plus R divided by R plus RC into VC. Same thing you apply for the current in capacitor current IC. IL minus I naught is equal to V naught by R. Take a IL here, put the value, then find IC R into IL, put the value of R V naught here, sorry, V naught here, and find R into R plus RC minus VC divided by R plus RC. We have two equations here, then V naught and this one IC. This I am written like R plus RC. R plus RC is equal to a constant A. R easy solution.
Sir.
Okay. Yes.
Sir, small doubt. In the IC expression, for IC is equal to IL minus V naught by R. So if we substitute V naught in the final expression, so it will be R RC by R plus RC IL. Like that only it will come. Plus R by R plus RC.
Here you have confusion here.
Oh, cancelled.
Okay, I saw. IC is equal to IL minus V naught. V naught is given like that.
V naught is R into RC by R plus
R
RC
into RC divided by R plus RC into IL minus R divided by R plus RC into VC. Okay, and divide by R.
Yes, sir.
Total divide by R. R cancel out.
Yes.
Take R plus RC common in IL. You can take R plus RC common in IL and find R plus RC minus RC divided by R plus RC into IL minus here VC divided by R plus RC. And then this RC cancel out. IC is equal to R divided by R plus RC into IL minus VC R plus RC. It's okay?
Understood, sir.
Okay. And take a common R plus RC like A. You take like that, then you also written IC is equal to A into IL minus VC is equal to A by R into VC, because of R present here. Then 1 by R plus RC is equal to A by R. Same thing you can written here, R plus RC to A into RC into IL V naught plus A into VC. Then switch, this one is a Q, S, this one S bar, and Q is equal to 1, this switch is on. Then if you switch on, this current flow like that. You take a VL and VL and IC, two equation you find. Then I will written directly VL like LDI by dt. Vs minus this one, current is flowing same here because of this one open circuit, and this current flow like Vs minus this voltage drop IL into R1, and this voltage drop plus IL into RL, and minus V naught. V naught is given here, you can written directly dl by dt minus, and I am taken IL as a common. Put the value of V naught is equal to R RC divided by R plus RC. R RC is A RC to IL, and V naught in common by IL, then find R1 plus RL plus A into RC, and then negative, the negative sign here, A into VC. Question number first. Plus I think this one is only when switch is on. You can, sorry, this one switch is on. When switch is on, Q is equal to 1, and when Q is equal to 0, then find DIL by dt. Same thing, Vs is not present, and remaining portion is same. This current flow like that. This one is closed, this one is open. Vs not present, and remaining portion is same. Minus IL R1 plus RL plus A into RC minus ABC. This one is Q is equal to 0. Combine both. You combine, then find LDIL by dt, final question. This one multiply by D, and this one multiply by 1 minus D. D into Vs minus IL R1 plus RL plus A into RC minus A into VC plus 1 minus D. I taken like a minus because of this. If you common, this is negative. Remaining, leave it, minus IL R1 plus RL plus A into RC minus A into BC. Solve this and take a perturbation observation. Then I am writing directly, solve it by yourself. Perturbation, take a Vs as Vs plus V cap, all remaining portion. Then find dVs plus d cap Vs minus IL. If you solve this, you find this portion is common for the both. Once this portion and this portion is common for the both, that it means that d cancel out, only this portion is remaining. If you then find IL is equal to IL plus IL cap, and D, find D is not present in this equation, then only IL cap is present, and we find R1 plus RL plus A into RC, and this one is a VC minus VC is VC cap. This is only question number first. Sorry, this one is question number. Take this one is the first. Take this one second. Same thing apply for the current. Capacitor current C dVc by dt when switch is on is equal to 1. Both in buck converter, both have condition is current is same in the capacitor, and same flow because of this circuit is present in the both condition. T is off and D is on. That's why IL is like RC IC minus IC plus I naught, and find IC is equal to like that. R divided by R plus RC into IL minus VC, same thing, R plus RC everything. So A into IL minus A by R into VC. And switch is on, switch is off. In both the conditions, same equation is same. That's why I written here direct C dVc by dt at perturbation apply. A into IL cap minus A by R into VC cap. Question number 3. Okay. Find the matrix like DIL cap by dt and dVc cap by dt. Something, this one IL cap and VC cap plus something here and D cap. If you take IL, inductor state, this one is the IL only, minus R1 RL plus ARC minus R1 plus RL plus ARC divided by LA. If you take a di by dt, then LL is common here. And VC is A by L, this one minus A by L, this one A by common IL is A by C, this one minus A by RC. And D cap present only here, Vs by L, sorry, or a D cap, yes, Vs by L. And if you take a Vs also, here one thing, Vs cap also, then find D by L and 0 Vs cap. This one matrix of A matrix. Written like X is equal to minus A inverse B into U is equal to Vs. And this one is Vs, take this one is B into U is Vs. Take this matrix inverse of this matrix. I put value here X equivalent like B. A matrix inverse of the second order matrix, replace this one is the interchange and this one is minus, this one will interchange, and this is a sign change of this element, minus A by RC, this one plus A by L minus A by C, and this one is minus R1 plus RL plus A into RC divided by L into this one is the cofactor matrix divided by in determinant. I have written B actually here. After that I written a determinant of the matrix A, like 1 by something. Determinant of this is multiplied by this one and this one minus this one. A into R1 plus RL, A into RC divided by RLC minus this one like A square divided by LC into Vs also present. I written Vs. This one A inverse, this one B, multiply by negative in the matrix. This one is positive, all of things. This one is negative. So multiply by here is minus 1 minus here positive, a into d divided by RLC. And this multiply by here is 0, and this multiply by here, then find plus a into d divided by LC. This portion is 0 actually. This portion is remaining into Vs divided by LCR. If you take LCR is common, and LC into bar here, then find a R1 plus RL plus a into RC minus a square into R. This one will multiply by this one minus, and minus and determinant, this one is plus, not a negative sign. Sorry for this. Because of this one negative, this one positive. If you take a determinant of this matrix, then this one multiply minus of this one plus. Take a common here and take a common here from this. A and D and LC also I will take common. A D in both matrix and element, and LC also LC, and find 1 by R here. This one is 1, and this one value will be S into LCR, and divided by, take a common, find R1 plus RL, a into RC, sorry RC, so a is common, a into RC plus a into R. Will cancel out, a cancel out, LC cancel out, multiply by R here, and find dVs to 1 divided by 1 into R. See here, this one R1 plus RL plus A into RC plus A into R, R1 plus RL plus, take common A, RC plus R, R1 plus RL, take a value of A is equal to R divided by R plus RC, so RC plus R, then RC, R plus R cancel out, this one only R1 plus RL plus R remaining, divided by R1 plus RL plus R. For the all of a value is given here in this. D is given 3.3 divided by 24. Vs is given 24. If you multiply by both and find only 3.3. R is given like 0.35. R1 is given 5 milli, and RL is given 10 milliohm. Multiply by here only 3.3 here, divided by 5 plus 10 is 15 milli, 15 milliohm plus 0.35, and here 0.35 divided by into 3.3. Find 9.04 into 3.16. To solve this, we take a transpose of this and find x equivalent is equal to 9.04 3.16 transpose. That's the answer of this question. This so last question I am starting here. So, thanks to all, and I think this is the last assignment, I think.
Uh,
Okay, thanks to all.